Okay, now let's see how we can find an explicit formula for v1 of s, the function. We already computed w of s, so this is really the last step. So we know that v1 of s is the maximum of s minus 1 and ws. We're going to do it visually, that way we can actually see. So let's recall the graph of ws. So this is what we had. We had 3/4 over here and 7/4 over here. And then beyond 7/4, we have s minus 5 over 4. Okay, and in between we have this parabola over here, and this parabola over here is 1/2 of s minus 3/4 squared. So this is 1. Okay, so this is w. Now we need to graph s minus 1. Let me use the red one over here. S minus 1, so 1 is somewhere over here. Okay, and 1 is smaller than 5/4, so s minus 1 is greater. It's a straight line, 45 degrees, so this is a 1. And this is s minus 1. So now we can actually see what this v1 of s is. So we have two functions, the red one and the black one, and we take the branch that's on the top. So what we have over here, so what we have is this v1 of s. This part is bigger, right? This is v1 of s. But after this intersection, it should be following this line. Okay, so the green line over here is the maximum of the red and the black. That's exactly what it means, that v1 of s is the maximum of s minus 1 and w of s. So we need to find this intersecting point over here, and that's s1. How to do that? Solve an equation. So s1 over here, we solve that. That means we let s minus 1 is equal to 1/2 of s minus 3/4 and squared. This is a quadratic equation. We can solve it easily, but on the other hand, let's get all the details so we can actually do it nicely. So we're going to call s minus 1 t. So s minus 1 is going to be equal to t. Okay, and then after we solve t, then s is going to be simply t plus 1, right? That's the one we have. And we know that s1 must be between 3/4 and 7/4. So we have this equation. So this one over here is going to be t is equal to 1/2, and s minus 1 is equal to t. So s is going to be t plus 1. So this one over here is going to be t plus 1/4 squared. Okay. It doesn't mean much easier than the other one, but I hope it can simplify this solution a little bit, and t plus 1/4 squared. Okay, so multiply them out. 2t is equal to t squared and plus 1/2 of t and plus 1/16. So we have equation t squared, and then it's going to be minus 2t plus 1/2 is 3/2t, and plus 1/16 is equal to 0. There's no easy solution, so we have to use the quadratic formula. So t is going to be have two solutions. It's 3/2 plus minus, and square root we have over here. B squared is 9/4 and minus 1/4. So we have divided by 2. Okay. So this is what we have. We have 3/2 plus minus, and this is going to be square root of 2, because 9 minus 1 is 8. 8/4, that's square root of 2. Okay, and divided by 2. We know this number shouldn't be really big because there are 2 over there. And since we have that S1 must be between 3/4 and 7/4, right? And then what it means is that T must be between -1/4 and 3/4. So this is when we are looking for. And if you see, if we choose the plus sign, then we're going to have 1.5 plus 1.4, that's 2.9. Divided by 2 is bigger than 1, so can't take that one. So we must have T is equal to 3/2 minus √2 and divided by 2. All this is going to 3/4 minus √2 over 2. So that's the one we have. So what it means is that S1 is going to be equal to 7/4 minus √2 over 2. So this S1, this value, which is approximately, we say, this is going to be 1.75 minus 1.41, and it's going to be 0.34, like that. No, that's wrong. Let me do it again. This is 0.7, okay, and that's gonna be approximately 1.05. Okay, so that's what we have. Otherwise, it's not gonna be right. So now after we get this value over here, we have the complete formula for V1 of S. So V1 of S is going to be equal to W of S if S is less than S1. Okay? And it's going to be equal to S minus 1 when S is greater than or equal to S1. So that's the formula. Now you may say what WS is. We have that formula on the previous page. Okay, so that's the answer for this part of the problem. And look at how we found it. We actually had to draw the diagram to help us to look at the intersection over here. But somehow we knew that this is what is going to happen because the stock price is dropping. So if you see the stock price is higher than a certain number, then you should exercise. So the conclusion now should be relatively easy because we have V1 of S is equal to W of S if S is less than S1. And it's going to be S minus 1 if S is greater than of S1. And S1, the value, is equal to 7/4 minus √2 over 2, which is approximately 1.05. Okay. So our conclusion is that if tomorrow is the last day, so here, this is the last day, and this is the second last day, so the day before, and this is the second last day over here, and we are looking at the stock price S over here, and we are determining whether we can actually exercise the stock option or not. So our conclusion is that if S is greater than S1, then we exercise the option. Okay. If S is less than S1, then we wait till the last day, till tomorrow. The last day. Okay. So that is the conclusion of this model. Now you may say, what if we have two periods, more than two periods, and we can repeat this process? The process, of course, will be much more complicated to solve, but on the other hand, we can do from V0 to V1, then we can do V2 from V1, and then V3. Especially, we can program a computer to do this, and it's not going to be too hard to find all these reservation prices. So eventually, this model will help us to determine the reservation price for the stock option if there are still n days before it expires, and the current stock price is S. And then we have this kind of very, very similar conclusion. If the stock price reaches certain threshold, then we exercise today. If it does not, then we will wait for another day. Okay.